Now we see in Photoshop or any other program that the maximum value for red, green, and blue is 255. Why the heck 255? No, why not 100? Why not 200 or 300? Why 255? That seems like a very peculiar number. But before we get to that, now we understand that each pixel is expressed numerically as a quantity of red, a quantity of green, and a quantity of blue. So first of all, let's checkmark that concept. Digital photography is a photography that is defined by numbers. But why 255? We'll get to that in a second. So first of all, the important thing about being able to define information with numbers is that computers only understand numbers. Computers don't understand colors. Computers don't understand letters, characters. The letters of the alphabet, no, the computer doesn't understand that. And you say, wait a second, I'm writing all the time. I can, yeah, but in the same way that we use special numeric data to define colors, we do the same for letters. So you remember when you started learning the alphabet and the numbers and numeric system in school, and you thought, here is a clever way of writing in code so nobody can recognize me. I can use number 1 for the A, number 2 for B, number 3 for C, and so on. And so you could write entire phrases just using numbers. Well, that's exactly what computers do. Back in the days when the PC was invented, a little before than that, an American Standard Organization created a table of characters so that if you were writing a certain number, that corresponded to a certain character. And that table, that standard, was called the American Standard Code for Information Interchange, or ASCII. So the ASCII table defined a table of letters, numbers, and symbols that were used commonly in the American society. That's, it's called the American Standard Code for Information Interchange. And that was invented in America, so the people who standardized were familiar and concerned with the American alphabet. And so they decided that certain characters would be represented by certain numeric values. That is how we have digital information. Numbers that represent letters. All right, so where is this all this going? Well, let me explain here. How we represent numbers in the computers. You might have heard of binary code, or you might have seen some graphic in the newscast when they are talking about technology, and there is this thing in the background with 010111000010. Why is that? Well, there is an important thing, an important concept to remember. A computer is an electronic device. So I want you to do something right now, a quick test, okay? If you are in a room, go to your light switch and flip it. If the light is on, turn it off. If it's off, turn it on. Now, I know that this seems like an absurd test, but I wanted you to really do it because physicality is important. You understand the light either is on or off. Only two states. There cannot be some other things between the current, electricity is not going and electricity is going. There are only two states. Why is that important? Because computers work in the same way. A computer is just a processor, I would say, a computer processor, CPU, is an incredibly complex, intricate series of circuits that at the very basic are made of transistors that are designed to let current pass or not. And that condition is only expressed by binary numbers. Numbers that can be either 0 or 1. Now, we are used to our numerical system, our decimal system, and you have learned the system so long ago that you don't even think about it anymore. But there is a very, very specific series of rules for that system. Now, think about this. In my ancestors, the Romans, didn't use the same symbols that we use today. They were using the Roman numbers, remember? And still today, if you look at the copyright information for a movie, you will see that it is written with Roman numbers. So that is just to explain that whatever we are using today is not an absolute truth. It's just a standard. It's just a convention that we embraced a long time ago and we kept using. But it's just one of the many, many possible combinations. So a decimal system, from the Latin that means 10, is composed of 10 symbols. We have 10 digits from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 symbols. Okay. Now, if I wanted to ask you the following question, tell me how you count. You would just start rattling off numbers. And that's not what I'm asking. I'm asking you to explain how you count. Let's say that a Martian comes to visit us and they say, okay, do you know math? I say, yeah, of course we know math. What kind of question is that? Well, the Martian says, show me. And we say, well, okay, we count as 1, 2, 3, 4, 5. No. The Martian says, I don't understand this. Tell me exactly what you're doing. So, okay. So this is how you explain it. We have 10 symbols, and we write the symbols. And this symbol means the quantity of 1. This symbol means the quantity of 2, and so on. And the Martian says, okay, fine. He's nodding. I understand. Okay. That symbol there means the quantity of 5. Cool. Keep on going. How do you count? So imagine that conceptually we have this long string of numbers, like an odometer. Okay? You've seen it in cars. And we start with the numbers are all 0. Okay? So then we start with the rightmost slot. And we start enumerating all the symbols from the one that means 1 up to the last symbol. And that is 9. Okay. What do we do when we reach the last symbol? And your answer is like, you would write 10. Now you're jumping ahead of millions of different steps there. Well, not millions, but many different steps. This is how it works in a formal way. So what you do is you go one slot to the left. You increment that slot, and then you fill all the slots left to the right with 0. This is important. It seems ridiculous, but it is vital. It's important. Follow what I'm saying. Bear with me for a few more minutes, okay? So we move to the left, we write the first significant digit, and we fill the slots to the right with zeros. And then we continue incrementing again the rightmost slot, and when we reach the number 9, we do the same. We increment the slot to the left, and then we reset to 0. And then we reach what? 99. So what do we do at that point? We do the same thing. We move one position to the left, set the digit to the first significant number, 1, and then fill all the slots to the right with 0. Fantastic. Okay, what's next? Well, this is just to show you that this is how we count. And of course, you're thinking, big freaking deal. And it is, because if I was going to tell you this, I'm changing everything here. I'm not giving you 10 symbols. I'm giving you 2. Now you have only 2 symbols in your numeric system. And I know this seems like a ridiculous concept, but it does exist. A numeric system can be arbitrarily defined with any number of symbols. And so we are using only 0 and 1. Why? Because computers only understand 0 and 1. Why? Because they're made out of just an enormous amount of switches. I'm oversimplifying here, but that is the essence of things. Okay, so now you have 0 and 1, and the first impression there, the first reaction is, I can't do anything with this. No, you can. Because now that you know how to count, you scientifically know how to count, you can do it. So we start with all the slots again as 0. And then we look at the rightmost slot and we write the first significant digit, 1. And then we are out of symbols. We reach the end. It's like, oh, what? Yeah, we reached the end. So what do we do? Simple. We remember the rule. We go to the left and we write 1 and we fill the rightmost slot with 0. 1, 0. It's not 10. The 1, 0 is the binary representation for the number 2, for the quantity 2. Remember, we start with 0, and that's 0. 1, 1. Then we move to the left and fill the right with 0. That's 2 in binary. And then we continue incrementing. 1, 1. That's 3 in binary. And then we reach the end. Again, what do? We shift to the left, write 1, and fill the right slots with 0. 1, 0, 0 is 4 in binary. 1, 0, 1 is 5. 1, 1, 0 is 6. 1, 1, 1 is 7. Now you got it. Now you understand you can count in binary, and it works exactly in the same way that it does with the decimal system. Exactly the same rule. All right, so that was the end of part 2. There is one more to come. And please subscribe to this channel and make sure that you click on the bell so that you will get notifications when a new video is released. Ciao!